So let's look at systems of equations. That's going to be the first section. This is actually going to be like a two-part video. So I'm going to throw in substitution in as well. So this is just solving systems of equations, which means solving multiple systems of equations. And the first type of solving is going to be by graphing, and the second is going to be substitution. So let's look at our notes. This is just systems of equations. That just means two. Let me make this a little bit bigger. So it's just going to be two or more linear equations. So that's just like straight line pretty much. All right, so these are the different types of solutions you can have. So you can have one solution. That's where you graph two lines and they'll end up intersecting somewhere. And that intersection point is your solution, that coordinate. You could also have two parallel lines that have the same slope, so they'll never intersect. That means there's no solution. And then when you have the same line, so you could have two different lines, but they're the same exact line, that's going to be infinite solution. So let's look at two examples. Number one, we've got negative 5 over 3x minus 6, and we've got y equals 1 over 6x plus 5. So we're going to graph this. Let me try to zoom in so that you can see it. Okay. So we're going to graph these. Let's graph the first one. So this negative 6 is going to be our y-intercept for that graph. So we're going to start right here. And then we're going to go down 5 and over 3 to the right. So we'll go down 1, 2, 3, 4, 5. That'd be somewhere right here. And then 1, 2, 3. So that point would look something like that. So we're just going to graph that line, which on mine, it's not going to look as neat, but on yours, you need to use a ruler to make sure that you have a straight line, because then that'll allow you to make sure you get the right answer. All right, so let's graph the next line. So 1 over 6x plus 5. So that's going to be starting at 5 right here. Then we're going to go up 1 over 6. So up 1 over 1, 2, 3, 4, 5, 6. So that would get us about right there. And we just want to draw that line. And you can't really fully see it on mine because mine's drawn poorly. But where these intersect will be your answer. And mine's drawn poorly, but when you graph it, it'll actually intersect at about right here. And that point is negative 6, 4. So that would be your answer. So make sure that when you do these, each of these lines you graph, make sure that you're using a ruler, because that will give you the correct intersection point. And then we'll look at one more real quick. So we've got y equals 5. Y equals 5 is just a horizontal line through 5 on the y-axis. And then we've got y equals 2x plus 7. So we're going to go up to 7. So that will be our start point. Then we'll go up 2. So 1, 2 over 1. That will end up right here. So if I can actually make this straight. Sort of straight. So you can see that it intersects at that point right here. So right there. And that would be at, actually it would be before that. So my drawing's still a little off. It would actually intersect at negative 1, 5. So like I said, make sure when you graph these, you use a ruler, because you need your lines to be exactly straight through those 2 points that you graph or that you plot. And where the 2 lines intersect, that's your solution. If they're parallel lines, then then it's no solution. And if you end up having two lines that overlap, that's infinite solution. All right, so now let's look at solving equations algebraically. So one way to solve them is by doing substitution. And all substitution is I wrote the steps out for you here. So you're going to solve one of the equations for x or y, just isolate your variable. Then you're going to substitute that in for one of the equations or the other equation. And then you're going to solve. And then you'll substitute that answer in for your original equation. So what that would look like is, let's look at 7. So this says that y equals, both of these are y equals, so we have y isolated. So this top one says that y equals negative 7 over, or negative 7x minus 1. You're going to take that, since y equals that, you're going to take it from your first equation and plug it into your second equation for y. So that would look like this. Negative 7x minus 1 equals x minus 9. So all we did was replace y in the second equation with what y was equal to in the first equation. And then we solve. So we're going to solve this for x. So we're going to say plus 1 to both sides. Negative 7x equals x minus 8. Then we're going to subtract x on the other side. That'd be negative 8 equals to negative 8. Or negative 8x equal to negative 8. Then we want to divide, which we should be getting pretty good at solving equations now. So x equals 1. So we found what x was. Now we need to find what y is. So if we know what x is, all we've got to do is come back to our original equation. We can pick one of these two. Basically, we can plug that x in for the x here or the x there. I'm going to plug it into my second equation just because it looks easier. So that would look like this. Y equal to, instead of plugging in the x, we just found that x is equal to 1. So we're going to plug in 1 minus 9. So y equals 1 minus 9, which is negative 8. So that would be x and that would be y. And then your final answer would look like this. You would just plug it in like an ordered pair. It'd be 1, negative 8. That would be your final answer. So that's all you've got to do on those. It's pretty simple. I'm going to let you try the rest of these by doing that, and then we'll do examples in class like before. But that's solving systems of equations by substitution and by graphing.